All right, thank you for joining everybody. So today, more SQL. Uh, SQL is the sort of thing that is worth getting a lot of practice with. So for us to spend 2 days with it, given that there are so many things we only spend one day with, I hope that gives the indication. But I will also be giving more resources and encourage, especially if you're applying to jobs that mention it, to dig into the many SQL exercise websites and just literally get some reps in. It is an exercise. It comes. I remember the first job I really had to write SQL for. I came in with like very basic knowledge. Like I knew select star basically, right? And but I had to write a lot of SQL, and so I was just writing SQL every day for a month or two, and then you get it. It clicks at a certain point. So you've possibly already had that experience with Python. SQL is the next language you should pick that up with. You don't need to pick up every language under the sun, but Python and SQL are both pretty core in data science. If you want a third language from there, I don't know, try R. We'll talk about that later on. So, Rust, that is a danger. You are offering me a dangerous tangent. Sure. Name your favorite language while I start the questions thread. I could offer an opinion on any and every language, but I won't. Not right now. Other things to do. Offer them. I'll tell you what. If we've got time at the end, sure, we can have a mini languages Q&A. My opinion for today, though, is we're going to get more SQL done. So today we're going to meet the friendly elephant. And I assume, of course, that Postgres chose an elephant as their mascot because an elephant never forgets. I'm not sure that I've actually seen that written down anywhere, but it would certainly make sense. So what is Postgres? Well, Postgres is a database management system, a relational database management system. So if you see the acronym RDBMS, that's what this is. It's one that was made by somebody named Michael Stonebreaker. Pretty awesome last name. You got to wonder what his ancestors did. But apparently what he did is developed database management systems at UC Berkeley in the 70s, 80s, 90s, and beyond. And actually, on Thursday, when we get to some more current database systems, not to say, by the way, it's like SQLite and Postgres have both been around. They're both good. You should not fall for the old tools are outdated. We should always use latest, greatest. Sometimes old tools are what's reliable and what works. And especially for something like a database, that can really matter. So old tools are fine, and Postgres is still well maintained, but it has been around. Stonebreaker does have some more current projects, something called VoltDB that we'll talk about on Thursday. So in order to play with Postgres, we are going to use something called Elephant SQL. Elephant SQL is just a free hosted Postgres service. The reason I'm doing this is because I don't want to make you all jump through the hoops of installing Postgres locally. You may, if you'd like. In fact, I believe Conda can kind of manage it. I'm not going to step through it. I'm not going to require you to do it because there will still be platform-specific issues, I am sure. And you don't necessarily need a local Postgres installation. If anything, having it run on somebody else's computer is more representative of what the real workflow will be with Postgres, because with Postgres, it will be running on some production database. Or actually, I should mention, a better workflow than just directly as a data scientist working from production. Well, rather than me just saying it, can anybody think of some problems if, by production, to be clear here, there's a web application out there, all right? Say it runs, I don't know, say it runs, I won't go to any in particular. These are all web applications. Say it runs Slack. And say in the back of Slack, there's a Postgres database maintaining records. What would the dangers be if DevOps just said, "Oh, sure, give the analysts direct access to the production database so they can just do things, analyze the data where it lives." Oops, I dropped some tables. That's certainly a big one. Now, what if they say, "Well, oh, that's easy. Let's just give them read-only access." That's a thing. It's you can set permissions, so they only get to run select statements. And Quinn, that's a good point, knowing the contact points between languages. I can talk about it again, if time allows, we can bring that all back up towards the end. Yes, slowing down performance, leaking data, overloading the database. Dakota just put a picture of a bomb. I mean, sure. In any case, there can be problems. The best practice, and again, this is not part of your job description as a data scientist, but it's something that you might see or maybe even encourage, ask for, is for them to have a second database, a copy of the production database that syncs data into it, maybe once a day. So maybe your analysts, maybe you don't analyze data up to the second of live data. You always get data up to the previous calendar day, something like that. And it's its own database instance. So if you manage to nuke it or overload it or whatever, big deal. You didn't take down production, and if it's well written, it'll even just regenerate the next day from the production database, right? So, by the way, what was the topic we covered last week that might really facilitate setting up an architecture like this, where you got a production database, an analyst database, and they copy things and stuff like that? Yeah, containers, Docker, exactly. So just a little bit of connection here. But let's dig into actually using SQL a little bit. So that was just long motivation for saying we're just going to use it in the cloud, right? And you're all comfortable enough with that paradigm. Elephant SQL, if you didn't sign up for it, please do. It's very easy. They literally just require email address and password, I believe. Now, you only get the tiny turtle for free. If you want larger, more intimidating animals, you have to give them money. But, oh yeah, sure, you can even sign in with your GitHub account, I suppose. I'm going to make an instance. I'm going to call it Playground. And I'm not going to bother with any tags because I'm just going to make a single server. And now this is another step that you very typically see when you're playing with cloud stuff. So I will spend some time explaining this. You can ignore this. They don't really harass you about it as long as you stay on the turtle tier. But what's happening here is we have to select a region and a data center. And this is selecting where in the world your thing is actually living. The cloud is not a cloud. The cloud is not magic. The cloud is just somebody else's computer. Or really, it's a tiny piece of somebody else's computer next to tens of thousands of others of their computers and a whole building of computers. So I suggest you leave it on the default here. I tried this, and even though it lets you select, like I tried Iowa, and it didn't actually work, even though it let me select it. But if you're paying, of course, you could select. And in general, you should select things that are physically closer to wherever you care about. So if this is for your access, select something close to you. If this will serve customers, select something close to the majority of your customers. Again, the cloud is not magic. The fastest data can move is the speed of light. And it turns out that the speed of light is actually slow enough that it can cause latency if your data center is, in London and your users are in Japan or something. So AWS versus Google versus Azure. So I'll mention that a little bit since it's right here. It is, of course, its own rabbit hole. AWS for now, just because that's what I've already tested and I know will work. With a service like this, it probably won't make a difference, at least at the free tier, because what it will do is it just depends where they spin it up. Azure, for people who don't know, is Microsoft's cloud. And in terms of for your own use, well, we'll be using AWS. I'll be talking about that a little bit more at the end today. We're going to be asking you to sign up this week. they're all competitive and they all offer similar functionality. I wouldn't like, I have the most experience with Google Cloud-like tools for a variety of reasons, but I've used a little bit of AWS, and it's the big one. And I've used a tiny bit of Azure. It's always very weird paying Microsoft for a Linux server, but you can do it. So I guess what I'm saying is that experiment, and it's a sort of business use case decision you probably won't make. And a lot of the times, frankly, it depends on what business deals you get or on what salesperson talks to what executive at your company. So it's not always made for the most hyper rational of decisions. For your personal purposes, it's probably good to learn a bit of each. They all have generous free tiers. And I've even heard like big services. So it's considered best practice to not just depend on one data center, because even though these are modern marvels, right? Like the Iowa data center is amazing. It's incredible. It's in Iowa. If a meteor hits Iowa, the Iowa data center is going to have a bad day. So, no matter how much you depend on one data, like no matter how magical one data center is, if you depend on one data center, you're going to be in trouble. Well, what do? You have your code run in 2 data centers. And then if you want to be extra paranoid, have it run in multiple data centers across multiple providers. That way, if Google manages to break all their data centers at once by pushing something horrible, well, hopefully Amazon is still up. The likelihood of both Amazon North Virginia and Google Iowa going down at exactly the same time, short of an unprecedented East Coast to Midwest earthquake or something, is very low. So that's my 2 cents on data centers for now. We'll talk about it more later as time allows. Then that's it. You selected it, you create, you wait just a quick moment. And reminders, there is a question thread. I am following the chat in the chat, but questions you definitely want me to see, put them in the thread. And there we go. So what do we get? Apparently Stampy the turtle. That's what we get. And by the way, I'm going to be deleting this instance right after this video, because what you see here, this really is the authentication to the database. So this is a password, and this URL string has the password embedded in it. So this is also essentially a password. So treat these things as passwords. Mostly that means don't check them into Git. For now, you can just type them in, or copy paste them in manually when you need them. For actually deploying passwords, since a lot of deploys are based on Git, you use something called environment variables. But that's something we'll talk about in week 4. That is 2 weeks from now, week 4 of this unit. You can, of course, change the password if it leaks. And a lot of times these services, when I say change the password, they don't let you even specify the password. They just generate some new extremely random password. So what else do we have here? Well, there's all sorts of things. This is basically kind of a web app version of an administrative interface. There's no queries running, but if there were, this would be some sort of dashboard to highlight the slow running queries. So if you were the DBA, you could find out which analyst. Apparently the system itself is doing something, so that's fun. That happens too. But if an analyst was doing select star from everything, you could come here and you could check it out, and you could say, oh, that's taking too long. Also, there's this thing called explain. We'll look a little bit more at explain later, but if you run, so this is already a kind of complicated looking query, but what sort of language is SQL? How did I describe it yesterday? Or alternatively, what did I compare it to? It's declarative, yes, AKA a toddler. SQL is a baby that wants the bottle. It doesn't care how the bottle, it doesn't even really understand what a bottle is. It just knows that it wants the bottle. So it says select bottle from, everywhere, whatever. That's SQL. So this query is declarative. Select, get what I want, do some math. Yes, you can do division. You can calculate little metrics like total time divided by calls is average time, blah, blah, blah. From blah, 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 where, or, and then order, which I didn't really mention, but we'll get to that more today. It's what you'd think. It's how you order things, how you sort them. and then descending to order by to flip the order to be descending rather than ascending. But this is just a description of what you want. If you want to see how it happens, you can explain a query. Let's see if this works. If this doesn't work, we'll do it later. But that's what explain means. It tells you what the query planner is actually going to do. And it's a way to understand in more depth the cost of a query, which in this case is apparently so bad that it doesn't want to explain itself. All right, I might give up on that. We'll do explain later, but explain lets you peer behind the bottle, lets you understand how the toddler is going to get its milk. So there's other stuff here. Generally, you don't need to worry about these sorts of things, but if you want to poke back, and some of this you only get, oh yeah, so explain ran for you. Great, thanks for sharing. That is what an explain looks like. And it gives this little hierarchical picture of like, okay, overall it's sorting things by key, and then it does something inside it where it scans. A scan means it has to iterate over every row of the table. And that's what a select does by default. So, you know, I remember yesterday I briefly introduced the idea of nested queries, and they're very powerful, but they can be more expensive because they require potentially multiple table scans. If you want to make your queries as efficient as you can, try to get it all done in a single select. For prototyping purposes, sometimes it's fine to just be a little bit lazier and assume the database system will keep up. But it depends, and it depends on how much data you're using. So yeah, there's certain things you only get when you pay, but there's also a browser, which is in recovery mode. Let's refresh this and see if it stops complaining so much. All right, I'm not sure why it is so concerned. I deleted a database right before creating this database, so maybe that's why my Elephant SQL is not happy with me. But the point is you can do things, you can run SQL here. So it's a full interface. Yeah, there are no tables, so it should be fine. But you can do something like you can run a create table statement. Does somebody want to give me a create table statement? Any takers? Well, here, I'll run the example that I typed up in the training kit. So yeah, so Carlos, exactly, that will create an example with an ID, primary key, and a created at date, and that's not bad. Date is a native type in SQL usually. This example is from the training kit for today. I'm gonna create a table called test table, and the syntax here might be a little bit different. So in fact, I'm actually highlighting something that Postgres has that I don't think SQLite natively supports, or at least it might be different to support in SQLite. So there's 3 columns in this table that I'm creating. One of them is an ID column, and it's a serial primary key. That's how you specify it in Postgres. So the words change a little bit, but it's the same sort of thing that you're used to. It'll be 1 for the first thing we insert, 2 for the next, etc. We don't have to worry about it. Name, varchar, up to 40 characters. And what does not null mean? Yeah, it's a constraint. Another handy thing that SQL can do is it can enforce constraints, and that can be really valuable. You know, all those required fields when you fill out a form on a web app. I mean, those might be validated first by JavaScript, but they're also perhaps validated in the backend. You know, they try to insert it in the database, and if it's a constraint like no, users must have a name, users must have a credit card number, something like that, then these will be not null fields. And this guarantees that data will only be inserted. SQL tables are always in a valid state. That is part of what, again, we'll be getting to in more depth on Thursday, the ACID guarantees of relational databases. Yes, serial primary key is a type. I think serial is the type, really. And then primary key is the indicator. And you can have, if you just say key, then it's a key, but not a primary key. It could be like a foreign key or something. If it's a primary key, so all keys have indices, but if it's a primary key, then it's unique for each row. So I think technically serial is the type. And this varies. If I recall, MySQL is something like auto increment, auto increment int or something. That's how MySQL describes it, I think. But these sorts of little differences of how you specify schemas in different databases are not worth memorizing. They're worth being aware of and looking up in documentation when you actually have to make a new table in a new database system. Plus, the other thing is, as we'll talk about a little bit more later today, you might get to the point, well, first off, it might not be your job to make the tables in the first place. But even if it is, you might use something called an object relational mapping, which I very briefly showed yesterday, which means that you write actually classes to represent your data and the SQL is generated for you. All caps is basically a convention these days, but you should stick to it. So keywords pop out. All right. So, and I didn't explain this last field here. What, yeah, you could probably not cap these if you wanted, but I'm going to cap them. This last field is pretty spiffy. What it is, it's a JSON field, and it's just an arbitrary JSON blob. So you can have in a single field in the table, arbitrary JSON data. That's a pretty neat function that Postgres is pretty good with. And it even lets you get a little bit of, well, we're going to introduce Mongo tomorrow anyway, but it already lets you get a little bit of that sort of functionality in. So we set up the database instance when we clicked through that stuff earlier that said, oh, let's do it in Virginia. That was the database instance. And the database supports multiple tables, really as many tables as you want. And technically, you can put in completely random unrelated tables in the same database. That's arguably not a good thing to do, at least in a production situation, because it gets confusing, but there's no real rules about it. Anyway, query completed, green check mark. So I created this table, and now I'm going to insert things into this table. So I'll leave this here, but I'll delete it afterwards. I'll leave it here so we see the schema of the table we're inserting into. But insertion works like insert into, and then the name of the table. And then we can say what columns we are giving it. And I'm going to give the name and the data, and then values. And then what you can do is you can give multiple rows of, this will not, like dot, dot, dot doesn't work here. But the point is you can give potentially a whole comma separated list of name and data in parentheses. So for instance, you can give a row name, and then you can give null. Null means nothing. Now, I'm giving null for data because I do not have a not null here. I'm allowing the data column to be null. I could not, if I gave null for the name, the database would complain. Maybe I'll even demonstrate that afterwards because it would violate the constraint. And of course, I can give something, I could give actual JSON here. Somebody give me some JSON. Give me a JSON string to put in here. I'll call this row with JSON. Great. So name, and yes, you do need the quotes for strings, and it's outer single quote, so inner double quotes are fine. Name John, age 30, and I'm actually going to, so yeah, you could do null or undefined. Yes, varchar, varied length character, exactly, Quinn. You do not need to be 40 characters, you can just be up to 40 characters. The other sorts of JSON is powerful. It's not just simple key value pairs like this. It can also be like, let's see here. Well, it's a silly name, but you know, you can have something. The keys always have to be strings, but the values, for instance, can be lists. The values can be lists. The values can even be other JSON objects. JSON objects can have JSON inside them, so you can nest them arbitrarily. Overall, they're kind of like Python dicts. Then this tells Postgres that this is not a string, that this is actually a JSON blob. So it's sort of like casting the type. And I'm going to go ahead and just run these two. So we're inserting into the table a row name null and rows with JSON. Zooming in didn't really work. All right. Oh, it didn't like something. What did it not like? Must have a typo somewhere. Name John, age 30. Oh, thank you. I'm missing the closed curly brace. All right, query completed. Now, if we do a select star from test table, these examples are very similar to what's in the training kit for today, so I'm not going to drop these queries in the Slack. And there we go. These are the two rows we just inserted, a row name with null data and a row with JSON. And people who've done web development, this might look a little familiar. This is sometimes what JSON blobs are represented as in a JavaScript REPL without investigating them. So I do wonder if we say select data from table where ID equals 2, will it still just say object object? Yeah. So it's not the nicest representation, but the data is there, and we now have data in the cloud. So that's pretty cool. Let's take a quick break for other questions, and then I want to show interacting with this more programmatically. All right. So one other thing that I will show is there's this thing. So this was all just the interface that Elephant SQL gave us, right? There's this thing called Postgres admin, PG admin, and it's linked to in the training kit. But if you install it and run it, it actually runs as a server locally. It's a local web app, so it's running on my local host. And this is kind of the Postgres equivalent of the SQLite DB Explorer. This lets me connect to a server and administer it and look at it and run queries on it and those sorts of things. So it's more powerful than what we have here. I'm not going to show it in depth. Well, I'm not going to show it at all. I'm mentioning that it exists. If you're curious about it, again, these links are all in the training kit, but I'll drop this specific link. Elephant SQL has instructions for how to use pgadmin to connect to their stuff. The short of it is you say add new server, and then you fill out the username and password and host based on the information you get here, right? Fairly straightforward. But as I said, I'm not going to step through that because we have enough to cover. So what we are going to do now is we are going to use something called Psycho. Psycho is, or Psycho 2 actually, is the most widely used database adapter for connecting to Postgres from Python. So it's essentially the equivalent to importing SQLite or SQLite 3 as we did yesterday. The difference is it's not built into the standard library. And the other difference is it's a little bit, yeah, PsychoPG, the PsychoPG2. The other difference is, and this is something that I just want to set, it's a little tricky to install. So I'll explain why, and I will give what I'm hoping is a good flow for most people to install. But we will help with issues as they arise. Or actually, you know what? For demonstration purposes, I think I'll actually use. I want to go back to the comforting world of Google Colab for this, just for a quick second. No, no. All right. Well, we'll try locally first. The fallback, I believe this is included in Google Colab. All right. So, see my terminal okay? All right. So what's tricky about PsychoPG2 is there are two versions of it. There's the version that is installed from source, and there's the binary version. And Conda has its own packaged version of it. So my first suggestion, what we're going to try to do first, is install Conda's version of it. If that does not work, then I would suggest using pip or pipinv, whatever you prefer. I'm not going to enforce things on you for this, but using pip or pipinv to install psychopg2-binary. So let's first try conda install, and I think I want like -c. Maybe I don't even need that. Conda install psychopg2. Let's see how that behaves first. And I know that you all have Conda. So hopefully this works for people, but I'm not 100% sure what Conda is doing behind the scenes, if it will work as smoothly on all platforms, etc. Certainly thinking. I believe so. Yes, psycho, spelled like that without the H. So yeah, yeah, John, you without the H. As always, Conda has to solve things. Okay, and it's telling me that it's going to update Conda itself. It's going to install libpq, which is a Postgres library, and it's going to install psychopg2. Psychopg2 depends on libpq. Conda is handling all this for us. The difference between psychopg2 and psychopg2-binary is the binary version is already built and has fewer dependencies. So I'm going to proceed and hope that this works. Yes, -c anaconda. Does that result in anything different than this, Mark? Because you're right. That's what they put in the instructions. I guess I should check just in case. I think that's just telling it to pull Psycho from the Anaconda channel, which I would think is the default. But I'll try it both ways. Yeah, I mean, the documentation gives that specific command. I think it probably won't make a difference in most situations, but I am testing to give you all time to follow along too. Yeah, I think you're fine, Quinn. And sure, you could even do it from the GUI. Wow, apparently the environment is very difficult to solve. I feel like there's a message here. Okay, A, you got access denied, like a permissions error. Yeesh. Apparently I should have gone. Oh, it's done finally. So actually, this is suggesting different stuff. -C is including various certificates and OpenSSL. So -C might be the right way to do it. I'm going to go ahead and run along with -C here. Although at the same time, the following packages will be superseded by a higher priority channel. See, I don't really trust Anaconda. That's why I prefer pipenv. I feel like every single time I run Anaconda, it solves the environment differently. And it forms different opinions of what it wants. But I'm going to continue anyway. Yeah, I don't. Conda does feel stochastic to me. I would agree with that, Zach. So exactly, Daniel. I get nervous when Conda likes changing, downgrading, and upgrading all the things all the time. Should you be? I mean, it's fine for ad hoc data science purposes. If I was touching production code, I wouldn't want Conda running in it. I would want something like pipenv, where I feel like I kind of understand what's being installed and why. In any case, I think it's working, and Conda is handy. While we're waiting on this, a heads up that apparently right at 11 a.m. Pacific, Austin is doing some sort of live AMA on Periscope, which is what, like Twitter's video thing. So I will try to end promptly at 11 or maybe even a minute or two ahead. All right. I think it worked. Let's find out. Yay, okay. If you're able to do this after waiting for lots of things, that means that you have Psycho PG2. So what we did here was a lot like this. It's just we had to wait. We imported a database connector. It actually will give a really, really similar API to what we had yesterday. And as an aside, kind of almost more of a software engineering topic, API does not just mean online service that returns data when you ask for it. API means standard way of defining an interface. And so a database API does not necessarily mean a cloud service. All right. Samira asks, so you usually have NumPy pandas from Conda and the rest from pip. I usually use Conda or Colab for exploration, and then pipenv when I want to reproducibly put things together. Pipenv and or Docker. Again, because I just feel like those are more deterministic tools. I do get this feeling from Conda that I'm building on shifting sand. It's still a great tool. I do not mean to rag on it, and it hasn't ever horribly blown up my system or anything like that. And the other good thing about it is you'll even see everything that Conda does is installed in user local Anaconda. So your worst case scenario, if Anaconda ever really ticks me off, I'll just rm-rf user local Anaconda, and that's the end of Anaconda. It doesn't mess up your system. It just isn't as reliable, in my opinion, or at least as understandable as some of the other tools. It's trying to solve a hard problem. All right, so let's talk through things a little bit here. There's something called psychopg2.connect, or no H. You know what? Do this again, and I'm going to alias this thing. Import psychopg2 as pg. There we go. All right, so there's something called connect. And connect connects to a database, but it's a little bit more complicated than SQLite, because with SQLite, we're like, hey, here's the file. That's the database. That's it. It's right here. There's no authorization. It's a file. Do what you want. What we need is we need to specify the name of the database, the user for the database, the password for the user, and the host. So, and yes, Mark, Conda does support multiple environments. So, maybe there are some hardcore Conda people out there who just understand it better than I do. I do not mean to rag on Conda. Sure, I can post some of my history afterwards, or I might just highlight the top commands here. I mean, I think the only command that I've really done and gone through with was the official, I'll say, conda install -c anaconda psychopg2. That's the only real thing I've done. And other than that, I've just fired up Python and played with it some. So I'm going to go back to my browser for a second, though. I'm going to go to my friend, the turtle. And I'm going to grab these things. This is the information I need. Now, please grab your own. Do not grab mine. And I'm deleting this afterwards. If more than 5 people try to connect to one of these free databases at once, I think it doesn't work. So please don't do that. Connect to yours. The username and the database have the same randomly generated name. So the user and the database are both quafkuskd for me. Technical term. So I'm going to grab that. I'm grabbing these and pasting them into Python. I'll show you afterwards, but I'm going to keep this shared for now. All right. The password, of course, is this thing, and make sure to get all of it, but make sure not to get any extra spaces on either side. And then the host, I happen to live on Stampy, which sounds like a wonderful home for a turtle. All right, so that's all the things we need. I'm going to switch back to the terminal now, but hopefully you grabbed similar for you. And I just went ahead and assigned these to variables just for my convenience / documentation. I'm not going to paste this one out for you. You should type your own. But your DB name, your user, your password, your host. And then assuming you've done that, you can make your connection. And I'm going to make it kind of like we did yesterday. So pg.connect, DB name equals DB name, user equals user, password equals password, host equals host. I'll go ahead and share this at least. And it takes a second, because what this just sent a bunch of bytes back and forth between the Northwest and Virginia, I think, is where I told this database to live. So that's pretty cool. A little bit longer than just loading your local SQLite file, not that long. And what do we get at the end? We get a connection object with all sorts of things in it. And guess what? It has a cursor, right? And if we make our own cursor and we say, I don't know, execute a query on it, like select star from test table. There's that table that you saw me set up in the browser. And I saw a discussion yesterday, oh, do you really need semicolons? Yes, you do. Don't get me wrong. I love that you all ask that, because I really don't like semicolons. It's purely arbitrary, and but it's one of the nice. Python just feels clean, doesn't it? Right? And you all have been immersed in Python, so maybe that's why you asked. But most other languages, including SQL, you should have this sort of end of statement thing. Syntax error in your password. Maybe you got a new line in there when you pasted it? I'm just guessing, Quinn. Yes, queries will run without, I think it might even run without it in Postgres, I'm not sure, but it is the norm, because the reason you don't need it in Python is because Python has all those really strong opinions about white space. And by the way, people who have lots of programming experience outside of Python and then come into Python, sometimes they get driven a little bit crazy by the white space thing. They complain about it because they're used to having liberty with white space. I am used to and like Python's white space rules. I think that you should always use properly consistent white space regardless of language. But any language that doesn't have those white space rules, it's a good idea to use these semicolons, because that's kind of like, that's where the rubber meets the road. That's where, no, this statement stops here regardless of white space. So yes. All right, let's go ahead and execute this. Nothing happened. Well, that's because, as with SQLite, we told the cursor to execute, but we have to fetch. So, well, as with SQLite, we can fetch. And I think is there even the exact same thing? Let's find out. There's the exact same thing. And it works almost exactly the same way, right? What is it doing? Well, it's executing this query, and it's fetching all the rows that correspond to it. And there were actually 2 rows in this case, because we inserted 2 little test datums, and it returns them as a list of tuples. And check this out. What did it do to the JSON? What data structure is that? That is a Python dict. Oh yeah, that is nice. That is convenient. That is the structure that we all know and love. You could throw it to a data frame if you really want to even. Oh, Quinn figured it out. Apparently pass, yeah, pass is a keyword. You don't want to define things to be pass. Good call. And if you're doing this in an editor, it'll highlight that a different color to warn you. Of course, in a REPL, you don't get that niceties. But yes, you could have this lovely situation. Oh, pandas will love us even more. In fact, let me We're gonna have a break soon, so let me foreshadow a little bit of what we're gonna do after the break. So let's say we have let's even make a data frame out of that dict. Why not? Except, can I fetch again? I'm gonna have to execute the query and fetch again and actually save it. Okay, so the second result, the third value in it, that's a dict, right? That was our JSON blob that we threw in there. And so I'm going to make a data frame from that. Now I have a data frame. Hooray, right? That's pretty cool. Well, not typing very well. There's a toSQL and a from SQL method built into pandas. So we can pass it a connection. Now, I'm not sure if this will work with our, we will try. It wants to use something called SQL Alchemy, which is an ORM. So we're going to do some exploring too after the break. But the point is yes, pandas can play very nicely translating things to and from SQL. Let's see here. So Chad, import error, no module named psychopg2. Did the installation look like it succeeded for you? Then maybe you need to activate the environment or make sure Conda's on your path. Follow up with a PM to get some one-on-one help on debugging that. But those would be my two guesses. Any other questions before we take a quick break? So I know this is all like small toy stuff, but this is cool what we're doing. We're interacting with a real database in the cloud now, and you could actually build production sort of things interacting with a Postgres database. I would actually encourage you to consider Postgres, and even for some things, although the free tier is really small, it's 20 megabytes, but Elephant SQL can be a great way to do a little quick prototype project and actually put it out there. Have it persist. All right, let me get to the browser for the timer. All right, when we come back, we're going to work on actually loading all the data from at least one of the tables in SQLite into Postgres. That'll be fun. It'll be a good stretching exercise. There's multiple ways to do it. We might do it the really simple, direct way first, and then we'll see if we can do the fancier things like toSQL and make it happen automatically. So that's what we'll do when we come back. Thank you, everybody. Yes, I will post. I might even just copy paste the whole terminal stuff. We'll see. I will post the output that I'm working on, but let's get back to the terminal and keep trying things out. All right, you all see this? You all even get to see my typos if I copy paste all this. So, all right. So what I'd like to do now is I would like to get all the data from, let's say, the main character table from the SQLite RPGDB, and I would like to insert it into the Postgres database. So that's the open problem. We've got about an hour to do this. Somebody get me started. It's just us and a rather Spartan terminal. We don't even have the built-in help, but I'm going to keep it that way. This is hard mode. Pretty sure we can do this, though. And I'll start. What do we need to do first? That's a hint. Yeah. And we're going to need to read the data from yesterday. So how do I do that? Yep. So you're all saying right things. Bonus points for working code, though. So I'm going to call something like RPGDB. I'm sure people are typing this. I'll type this one out, but think about the next stuff then. So connect, and I think I'm actually in a different directory, so I'm going to have to be a little bit tricky here. But it's module one. What is it exactly? What is the name of the module one directory? Module one, introduction to SQL, rpgdb.sqlite3. It'll give me a file not found error if I mess this up. So, and it didn't, so we're good. Your path may vary, but if you're working from the module 2 directory like I am, it'll be like this. The point is, use SQLite3 to connect to your SQLite3 database. You did that yesterday, so you can do it today. Now what? And I'm going to specifically say I want the character creator underscore character table. I want to get everything out of that table. Yeah, that's a good point, Shreyas. Should we create tables? And this is the upfront, and we're going to talk about this more tomorrow. This is to some extent why not everybody likes relational approaches. You can't just drop data in it. You need a plan. You need to have a schema. You need to do that create table statement. It's kind of fiddly. This one might take some trial and error and some looking up of documentation. That's okay. It's generally not worth memorizing. Even if you're a DBA, you don't create tables every day, or if you do, you probably really hate your database. So yes, import psychopg2. I'm in the same session. I still have a connection, so I'm going to keep this session going. But absolutely, import psychopg2 and get your connection going if you need to. I have it. I have a connection object to good old Stampy. And you'll see here that even it obfuscates the password. So that's nice of it. But it's connected, as we showed before. Yes, so we need to get a cursor. Let's get a new cursor, sure. And now we need to figure out a create table statement. This might take a few tries. That's okay. Do we want to start by maybe looking at the data from SQLite so we kind of know our target? I want to look at the first 5 rows of the character table. How do I do that? Yep, that's the query. And of course, to actually do it, well, things are going to get a little bit confusing here. So I'm going to rename this. This is the Postgres cursor, and this is the SQLite cursor, right? Something like that. And the SQLite cursor, we have the connection to SQLite 3. I made it here. I call it RPGDB. It's confusing. Good variable names are hard, but we're connecting to 2 databases at once, and that might be something you have to do in your code sometimes. And we want to execute. What do we want to execute? We want to execute select star from character creator underscore character limit 5, not limit 2, just limit. Dan, that sounds like a file not found error most likely, so double check your path to it. I typed this because I'm in the module 2 directory, so I'm going up a directory and then over to module 1, and then that's the file. And then exactly, so we execute this, and then let's say results, not the best variable names, but that's fine. And now we look at our results. Okay, these are what our characters look like. They're tuples, and it's like a number, a string, and then 1, 2, 3, 4, 5, 6, 7 more numbers. And the numbers all look like integers. So one integer, a string, 7 integers. And what's something to note about the string as we look at multiple observations? Yes, it's a varchar because it's got varying length. Um, you know what? That's a great point, Kaylee. From this alone, it's ambiguous. Are these zeros and ones Booleans or are they integers? I'm going to call them integers. I think most of them are integers. And for now, just for the sake of ease, that's what I'm going to call them. But if you have a bunch of values that are just 0, 1, that might be representing Booleans. And different databases have different standards. There are different sizes of integers. So for instance, there's something called tiny int, which I forget how many bits it is. Let me look it up. Yeah, a tiny int, it's a MySQL type. It's for very small numbers, right? So you for now, I'm just going to make everything regular int. I'm just going to do integers across the board because I know that'll work. If you really want to refine and make sure that you're picking the correct types, the advantage, if you know, for instance, that, oh, these numbers will never be bigger than 50, then you can pick a smaller integer type to represent them because that will actually save space. The database will allocate less memory for each integer because it knows that they're smaller. Now, if you ever try to insert an integer above that limit, then it won't work. These are the sorts of trade-offs that are good to know about. Maybe we'll talk about them more later. For now, I just want to get something working. And that's okay to have that attitude too sometimes. Con not defined. I defined con earlier. This was from before the break. And here's the code that I used to define con. So I'll leave this here for a second. pg.connect, and then this information should be from your hosted database. If you exited Python during the break, then you'll have to rerun this code. All right. So now there's one other thing we should note here. So I'm going to say by fiat, okay, these are just integers. There's 7 integer fields here. This is a varchar. And what is this? What's special about the very first value? Yeah, that's the row number, aka serial, aka lots of AKAs here. ID, aka index, aka I'm going to keep fishing. Key, yes, primary key. Not all the other answers were all correct too. But I was going to keep going until somebody said key. All right. Now, one other thing to make this, I guess, a little more informative, we'll peek behind the curtain here. So let me switch back to the browser. Exactly. How do we know the names of the fields? We should check this key. That's exactly what I'm going to do. So let's get back to our friendly elephant of the day. And I'm going to go to the source of truth for this data, the Django RPG web app. Now, again, you do not need to really worry about this. If you want to explore it, it's cool and follow the tutorial. It's totally stretch goal territory. I'm not going to talk about it really. So it's up to you if you're feeling like if you've got a SQL experience and this is mostly review for you this week, maybe check this out. But what Django does is it has these things called models. And models specify, using object-oriented programming, the schema for your data. And so here is the character model. And indeed, we see it really is a character ID That's the auto field. It's a primary key. Oh, thank you for sharing that, Mark, for people who needed that from the other screen. It has the names, which is a car field of max length 30, so a var car 30. And then it has 1, 2, 3, 4, 5, 6, 7 integer fields. So they really are integer fields, right? But they have names, the level of the character, the experience, the hit points, the etc., right? All the various statistics. RPGs are really just kind of weird statistics number games at the end of the day. Well, old school pen and paper RPGs. Now, don't worry about this right now. This is a specific Django magic thing. This is what tells Django to make that inventory table. Remember how you had to use the inventory table to do a multi-way join to connect the characters to the items they have? This is how that got set up. So it's pretty cool, by the way, that that entire table and all those relationships got set up with a single line of Python. That's pretty powerful. And that's why people use tools like Django. But for now, that's what that is. Otherwise, don't worry about it. These are the fields we care about. So I'm even going to drop them in a Slack block quote so I have them here for reference as well. Yes, a lot of stuff is happening magically here. See how this character class inherits from Django models, and then the subclasses inherit from the character class, et cetera, et cetera. And there's all sorts of magical things. We're not teaching you Django. In a few weeks, we'll teach you a little bit of Flask, which is kind of a simpler tool that will work better for a lot of basic use cases. But I mean, a lot of my professional experience has been working with Django applications, both like data from them and also the actual building of them. So it's a widely used framework. All right. But the good news is that schema kind of aligns with what we see here in the data when we selected, selected star from our SQLite table. We're like, okay, yeah, there's a key, a varchar, and 7 integers. Varchar and the 7 integers. That's a new Python fable. That's a really lousy joke. So somebody help me out here. I'd like to write a create table statement. And let's look up the create table. I won't switch back and forth for this, but Postgres create table help. So here's some documentation. Although that's 9.6. It's chances are this will work for us, but you might want to click the newer versions. So it's not that different from what we've already seen. What we want to do here, and let's even construct this as a string first. So we're going to call this our create character table. It's going to be a multi-line string. Here we go. Well, we know we start with create table. And let's just call it character. We don't need to put this whole preface in front of it. That's something that Django does. Maybe we should, just to keep it consistent. Character creator character. Okay, we're creating our character creator character table. And yes, I know, Mark, you saw the first iteration of our Django material, I think, right? Back when I was developing it. Yes, I'm leaning on that a little bit, but I'm not teaching you all Django. At the same time, this is on purpose. You will be working, you'll be a consumer of these things, even as a data scientist. All right, create table, and then in parentheses, separated by commas, the field names and types that we want to create. So somebody help me out here. What's the first field? Well, yes, name is the first field that's going to be sort of specified that we provide, but what's the first field in the schema? In fact, it looks like Samir already had. Samir, I think you're giving me working code. That's great. That's what I always ask for. Let's try it. So character ID, which should be, now we need to double check here. We did this earlier even. Postgres wants it to be a serial primary key, right? That's how Postgres thinks of it. Name, and is it actually called name? Let's try to use all the same. Yeah, name, and that's a varchar 30. Great. Level, or not equals, sorry. And yeah, level is an int. Experience is an int. Hit points is an int. String is an int. And I should say, Mark, yeah, we're going through this, but we're going through a different angle. We didn't write the SQL. When we did this with Django, we just wrote the Python. Django generated the SQL. Intelligence is an int. Of course, it's a little bit dubious reducing something like intelligence to a single number, but we're going to do it anyway. And wisdom is an int. Let's count 1, the ID, the string, 1, 2, 3, 4, 5, 6, 7 integer fields. That's looking promising. And then, of course, we close the parentheses and put our semicolon and our triple quotes. Because I'm not executing this. I'm just assigning this to a string. So I can even double check the string that I've got. And yeah, that's my create table statement. So let's try to do it. How do we execute it? I'm making you do this the hard way. If you were doing something in production, you'd probably figure out a way to like use data frames or an ORM to automatically translate between the two databases. But I think it's valuable to look at it and see what these systems do for you automatically, because it's not magic. They're just running their create table statement that they figure out. What happens if we add a typo as we add lines to that string? The world collapses. I mean, you might need to redefine the string, especially if you're here in the command line. It's a little bit hard to go back and forth. I admit that. Of course, honestly, maybe that's why you should be working in an editor. I'm using a terminal here because that's giving me the most flexibility to demonstrate. You don't have to follow around in a terminal. You can follow along in whatever environment of your choice. But yes, execute. And where are we executing it? Well, we don't want to execute it in the SQLite one because the SQLite one already has this table. In fact, I wonder, we could try. Let's see what happens. First off, it's also SQLite, so it uses different logic for, like it uses different syntax. But let's see an error message. Yeah, the first error message is, hey, that table already exists. Now, sometimes you'll see things like right before create table, you'll see drop table. Yeah, so that, drop and then create, right? Or create table if it doesn't exist. That sort of syntax can happen. But yes, we want to use the Postgres cursor. And let's execute our create table statement. Okay, no complaints. I think we did it. By George, I think we've got it. I'll share this string then for people still fighting with it. You can, if you'd like, just do something like create character table equals this gobbledygook. And this is a single line string, but it has all the new lines embedded in it that it needs. That's how Python prints multi-line strings once you assign them. So how do we actually test this? Well, let's try to insert these 5 results we've got. How are we going to do that? This might be a little tricky. For now, you can actually potentially do an insert and do this all in one insert statement. But let's think about this. Say, okay, for result in results, you can insert this one at a time. It's not the best way to do it. What we really want to do here is we want to say, okay, actually, but before I do this, let me even just look at results 0. Results 0. So this will be the first thing we look at. It'll be a tuple. Let's see here. What do we actually want from this tuple to insert? Here's a hint. We don't want to insert everything here. Yeah, we want to start from the name. This ID was auto-generated, and it will be auto-generated again. We do not usually need to manually insert key fields. Now, occasionally you might. Occasionally it might really matter even. But generally, it's best if you can set things up such that the database is taking care of that, because that lets it make various optimization decisions. So slicing works on tuples because they're iterable. So this is what we actually care about, right? Everything starting from the name. And if we say for result in results, let's make our insert result, and that should equal, let's see here, Postgres insert, drop the documentation link for this as well, but I won't go back and forth. Now there's an awful lot here. We do not need all of it, but that's the full documentation. There's all sorts of crazy things you could do. You can specify default values. You can apparently do recursion and updating and stuff. All we really care about, sorry, you all still see, kind of lost where it was for a sec. We want to insert into character creator character, and we are inserting literally every value that can be inserted. So I don't think we even need to necessarily specify the column names here. We possibly could, and maybe we even should, but I think what we can do is we can just give it all the values that are here. Although before I actually do this in the loop, let me get out of the loop one more time. Yeah, it is good to do. So maybe we'll type it all out. It also makes the code more readable. It's kind of a form of documentation. It's literate code to put all those column names in there, right? So I shouldn't discourage it. There is execute many. We're starting, what we're doing right now, inserting one at a time in a for loop, is inefficient. I'll say that right up front. It is not what you really want to do, but I think it's a reasonable starting place to be able to understand it and write it. So this is on purpose. Let's do one more thing here. Let's figure out the right way before we worry about looping to convert this into a string. If we pass this whole thing into str, what do we get? Honestly, I think we get exactly what we want, right? It's comma separated values in parentheses that it's a string. So that's exactly what we want, but I wanted to check first. So now let's go ahead and loop again, or loop for the first time. Sorry. Apparently, all right. And we're going to make our statement. It's insert into, we'll do it as a triple quote so we can do multi-lines here. Insert into character creator character. And then what are all the column names? We will not have to remove the parentheses. The parentheses are actually part of the insert statements, if you recall. We want parentheses for each row that's being inserted. Yep, so it's character ID. Well, no, we don't give the ID. Name. If I scroll up, it's right here in the Slack, right? name, level, exp, HP, strength, intelligence, dexterity, wisdom. All the various things that a person can have, apparently. And then what? Well, which values? And which values? Well, at this point, we can close the triple quote and we can add the string of this particular result that we're looking at. We're doing this in a for loop. Skip the very first value. Skip the key. Does this make sense? Are there any questions on this? Then all we need to do is execute it. How do I execute it? Yep, and it's the Postgres cursor, because that's where we want to put it. And we're going to execute this. And what else we're going to have to think about potentially at some point? We're going to have to think about committing it, right? Let's try running it without worrying about that and see what happens. Let's see if this works. Apparently, it didn't work because it wasn't called PG. It was just PG cur. Great. All this over again then. That's really annoying. All right. PG cur. You don't have to reinitialize the cursor, I don't think. But we'll find out. You just tell it to execute. Well, let's run it. Let's see exactly what issues we run into, or if this is adequate. As you've probably seen, I tend to prefer starting doing things simply and not anticipating more trouble. And then if I encounter the trouble, if I encounter the error message, well, turns out I did need that step, right? But that ensures that your code is not more complicated than it needs to be. Okay, it didn't complain at all. How can we check if our things are there? I think, Rudy, you might be right, by the way. This might not have worked, really, but it didn't give an error message. Let's check on things. Always verify, right? Okay, so pgcur.execute, select star from table that we just did, .fetch all. Oh, well, didn't even like this. Oh, and then pgcur.fetchall. So a slight difference between Psycho and SQLite. That would have worked with SQLite, right? Because SQLite, this returns the cursor object to fetch all on. Well, hey, I think that worked, right? That looks like exactly the same data. Results is, of course, what we originally fetched from SQLite. So the moral of the story is sometimes you don't have to worry about things. Now, it might still be a good practice. Yes, huzzah, indeed. It might, in fact, it is a good practice to think about commit. What commit does is commit tells the database, okay, I'm done. And we'll visit this more on Thursday, but it's how a lot of these, I've said, SQL has all these nice guarantees. You can't lose your data. Your data is always valid. The way it maintains these guarantees is with this idea of something called transactions, and commit is how you define the end of a transaction and tell the database, hey, you're good. Good job, right? Save it, print it. And yes, it even has the same character ID. Now that's pretty convenient. Sometimes it might not matter, but it's nice that that's how it worked out in this case. So I will share all this code, or really I will just drop this entire session in the Slack, at the end of the lecture. But is there anything else anybody would like to see or experiment with before we switch gears a little bit? And I want to talk about the challenge for the day and maybe explore some of these other things I mentioned earlier, or maybe have a 10-minute Q&A on programming languages. Okay, should we be doing all of this in Jupyter? You can. Jupyter, you could think of Jupyter as an IDE, as a little environment that lets you write code and see things. For the assignment, yes, you should be putting this in a .py file. I'm sorry, I'm just going to drop this as a summary of my interactive session for you all. You will have to clean it up yourself. You have to do some of that. I promise it's good for you. Again, I did it interactively for pedagogical purposes. I will say the other use case for doing things interactively like this is when you're just investigating a problem. When you're not ready to write code to check in yet, but you want to sort of connect and interactively check things out. I do this pretty frequently. The command line terminal is a bit more Spartan than Jupyter. It doesn't have documentation and formatting and stuff like that. So if you're used to Jupyter, use Jupyter. That's fine. I'm used to the command line. I assume that cursor needs to be initialized with SQL commands every time it needs to be executed. I don't think it needs to be initialized so much as it gets reset every time you run it. But that's something I'll dig into a little bit more to try to give you better caveats about. It's the sort of thing that, again, the real hardcore, like what specifically is a cursor doing and how do you really do it optimally, that's not a core skill that you need as a data scientist unless you're really leaning in a data engineering direction. It's a fine question to ask. It's a fascinating topic in its own right. Can you show how to insert as JSON and read it into a Python dict? Sure. Let's play with some of that. Any other questions before we do that? Because that might take us a few minutes. In fact, I think that might take that plus a very brief language Q&A, and then you're off to watch Austin's Periscope or just eat lunch, whatever you prefer. All right, let's do it. So insert as JSON. Do you want to insert an arbitrary dictionary? If you recall, going back to our PG cursor, we have an example table, creatively named, right? Oh, of course, I need the word execute. And I don't need the S. Great. Okay. It's not called example table. What was it called? Test table. I'm glad we did this. What is this telling us? Let's go back to do that first select. No, it is an error. We are still connected. So if we go back, let's see what lives in the character table. Yeah, it doesn't like what's going on. So it's forcing us to commit with 2 M's. No, should be called something like commit. You know what? Maybe we just need a new cursor. Maybe that's what's going on here. Maybe after we've written from this cursor. Or is it con.commit? Okay. And was con our, yeah. Con.commit. Okay, now let's see if we can start running queries again. Haha. What happened? Uh-oh. It's not that. I think this cursor is working. What's this message? Let's go back to the test table, make sure that that's okay. Oh, now it's freaking out still. Maybe we should make a new cursor. But yeah, so if we commit, and now we do this, our test table's still there. There's the stuff that we made interactively in the browser at the beginning of class. But I'm pretty sure, let me double check that there's not a typo here. That character creator character table that we made, it's gone. In the words of Christopher, poof. So, you know what? Turns out we should have done that commit all along. Well, you know what? I guess I should rerun things. It'll be a slight pain, but we have all those. Let's even do dir. All this stuff lying around in memory. We can rebuild it. So we have the create table statement. So let's start with that. Let's execute the create character table. Could we rebuild it in a different context to see how that looks? Sure. What do you mean by that? As a PI file. All right, I think we have time for that. But I'm doing it in Vim. Follow along with an editor of your choice. So, yeah, no, PI files make it easier to rerun code. That was like half the point of everything from last week, right? Do as I say, not as I do. All right, well, let's just call this RP, let's just call this Postgres example.py. All right, if we're writing a PI file, somebody help me out here. I'll at least start, I'll start working on formatting this string because it's kind of annoying. But somebody tell me the other stuff I need. Import SQLite 3. All right, I will make this a little prettier to look at while people type more code for me. Create character table. Da-da. So this is our multi-line string for our character create statement, character table create statement, that is. Great. I don't have to find and replace. Yes. So what if people also share it? Import psycho pg2 as pg. Sure. Let's do this proper. Let's put our shebang at the top. Let's even say something like example of moving data from rpgdp.sqlite3 to Postgres, something like that. All right, and this needs to be a triple quote. And what else have we got here? Well, I'm even going to define methods, so there. Maybe I won't. Maybe we'll leave it as this. So I'm going to say the pgcon is equal to pg.connect. Now I have to get all my. I don't want to. That's the other thing. Part of the reason I did this in the REPL is I'm not going to put my database and password and all that out there. So I will use these variable names and assume user defines database parameters. DB equals DB name, user equals user. Password equals password, host equals host. Great. If you don't add the shebang at the top, it doesn't really matter. It's just that's what lets you run this by typing Python and then the file name. That sort of tells it which version of things to use. And then sure, the cursor. And then we're going to want to do something like pgcurs.execute create character table. And then let's, up here, let's first get the data from SQLite 3. How do we do that? Connected to SQLite. Module 1, Introduction to SQL / RPGDB SQLite 3. And then let's just say results is equal to slcon dot execute selects. Let's do it for everything. Why not? Select star from character creator character. We did it with 5 in the REPL to make it easier to look at, but that's it. Dot fetch all. All right. Create table and insert data in Postgres. Postgres. All right. So now we're back down here. We're connected. And then we want something like for result in results. And how do we do that clever bit? Might even have to scroll up in this. If I exit, I'll be able to scroll up. So I'm going to do that real quick. Okay, we're going to have to clean up these dots. But this was pretty good, I think, right? So I'm gonna start from this. Oh, okay. There we go. So we do not want the dots. And there we go. So what's going on here? Well, we're making an insert into character creator character, name, HP, strength, intelligence, dexterity, wisdom, the results, and then execute that. And then now what should we do? Let's try actually committing it. Let's try telling the database, okay, you're done. What must have happened before was some sort of optimization where the select worked. It showed us what we wanted to see because the database adapter knew that that was there because it knew we just inserted it, but it didn't actually finalize it in the database. It didn't actually put it where it was supposed to be and tell the database to commit. And so when we tried to do other things that conflicted with it, by default, it aborts the transaction and it undoes everything that it did in the database. And that's why the table didn't even exist anymore. But if we tell it to commit and it successfully executes through this line, then it is forever. It is saved, it is robust, it is resilient, it is in the database. All right. And then let's see if this works. I don't think it, I mean, certainly maybe reusing the same cursor to select from different tables is not the best practice, but I think it was also just because after doing the insertions, we started doing other selections to other things. We just waited too long. I'm not sure. I'd have to really dig into what the database adapter is doing. Point is, it's a good practice to commit when you're done doing things. Now, you could even commit here, by the way. And if you committed here, what would happen is the table would get created. And then if this process fails, well, the table would be empty, but at least it would exist, right? Because we're adding like an earlier commit checkpoint. You could think of these as checkpoints. For simplicity, I'm just going to have the one at the end here. And now, how are we actually going to run this? Well, I need to define all those things. Let's scroll all the way up to where I defined them. All right. I'm going to paste this in, but I'm going to remove it before I share the code with you all. All right. Now this ought to work, right? It ought to do the things we think it should. Now that said, even though it's all in this, I might copy this entire thing and paste it into a REPL so I can then interactively continue to investigate what happens. Ah. Okay. So, ha ha ha. Okay. Apparently the copy paste did not do what it was supposed to do. Try with an import then. What did I call the file? Called it Postgres example. What I should really do is I should just put this in a method, and then that way I can say from Postgres example, import it, and then run it. Let's just try though. From Postgres example, import. No, put it in a method. Let's do it right. So what part do we need to put in a method particularly? Let's do all this stuff. Everything above it is just setup. So def make and populate character table. All right, and now if we, not the best editor for this, but it lets us see all the code again too. I'll just manually offset things so they're all inside the scope of this. Okay, now we actually have a module that we can actually kind of use. So that's nice. Great. Now import Postgres example. What's inside the Postgres example? Well, all the things we defined, like these long strings and our connections, even like the Postgres module is here, as is our connection to, oh, I guess it makes, does it make the connection inside that? I might have done that. Well, that's fine. If we do Postgres example dot make and populate character table. Oh, ha, all right. Because of how I ran things, I'm going to go ahead and drop the table real quick. And if you're in this situation, you can do the same thing. Let's make our own PG connection in this scope, which is pg.connect. DB name equals DB name. Host equals host. User equals user. Password equals password. Oh. All of these are inside Postgres example. All right. I'm going to do this one more time with less typing, worrying about commit and or close. That's not what this is, I don't think. Actually, to make this simpler, I'm going to change how it is in the file. I'm going to go ahead and connect outside of. Oh, well, that's great. That is not what I want in this file. There we go. Sorry that I'm moving a little fast. I just want to try to get this done ahead of 11. So I'm putting the connection outside of this scope so I can access it directly, just to make my life easier when I import the module. And to also make my life easier, I'm going to alias this as PE. So now inside PE, we have PE.pg connection. And I'm going to go ahead and ad hoc execute. I need a cursor even. Yeah, all right. PG curse is equal to PE.pg con.cursor, PG curse.execute, drop table. Take that. Oh, with a typo. Huzzah. PG curse dot commit. No, sorry, PG con dot PE.pg con dot commit. Something dot commit, that's for sure. All right. And now, presumably, when we do the make and populate character table function that we defined, it won't complain that the table already exists. But there's a typo in the method. And round we go. Let's check it out. PG curs with an S. Curses. Now, the good news is I shouldn't have to do that hack of dropping the table again, though, right? Because I put the commit at the very end. So the table should still not exist. Let's show that that is the case. So I'm going to import, and I'm going to skip all that other stuff I did. And I'm just going to say, hey, make and populate character table. It's taking a little bit of time. This is not the most efficient way to do it. I'm going to add a to-do. Try to not insert every row one query at a time. In fact, this is starting to take worryingly long. I'm going to peek at the admin web page, see if it's complaining about things. No, all right, it finished. So that should not have taken that long. We inserted, what, a few hundred rows. That would be way more efficient if you made it into a single insert statement. But, well, we didn't really make Elephant Postgres think. What we made think was all the network connections between my home and Virginia, because we did a complete round trip for every single row. So we just did hundreds of times the latency between here and Virginia, and that adds up, right? Again, the speed of light is not as fast as you think it is. It takes, some milliseconds sometimes to get someplace, and it takes a whole second to get to the moon, by the way. So, it takes however many milliseconds to get to Virginia, and a few milliseconds times hundreds of rows, that can be a few seconds, right? So the better thing to do, and what I will leave as a to-do, is figure out how to do this in one statement so there's only one round trip. And then it will probably feel instant. But let's verify that we did this, huh? So now I do have to remake my own cursor in this scope. But that's fine. That's probably a good thing. pe.pgcon.cursor. And now to verify that we have what we want, well, let's execute select star from character creator character, limit 20. We don't need everything. I always do a dot there. I don't know why I do that. And now let's fetch all. And there we go. The first 20 rows from aliquid to laboriosa of our data, but now living off there in the cloud. So I think that's a good place to kind of finish today. I'm going to defer the philosophical tangents on programming languages to some other time, though I encourage thinking about it. What I will say, Python is a pragmatic multi-paradigm language. It does what works, and that's what I like about it. You want to do something kind of functional, do something kind of functional. You want to write classes, write classes. There exist languages with stronger opinions out there, and that's fine. I am partial to the ML family, the meta language, not machine learning. ML stands for meta language, and it's a family of languages, OCaml and SML, and they are pretty fun. And I've always been meaning to learn Lisp a little bit better, but I don't know, I'll do that when I retire or something. In any case, that's my 2 cents. We'll talk about it more at some other later point. What went wrong initially for our understanding? I don't know what you're referring to specifically, Shreyas. And while people type, let me get back to the browser. I will drop this file with my passwords removed for you all. By the way, this is when I was running that bunch of inserts, I was trying to see, oh, what is it complaining about? I was going to the admin interface for my Elephant SQL. And yeah, something was taking some amount of time, right? But now the tables are here. Oh, the problem with losing the table. I think it was what was pointed out. We should have committed. You should run commit after you change things, right? That is a good practice. I don't think you need to always make new cursors for absolutely everything. I think that's probably but it's still a good idea if it's a really different purpose, different tables, different workload, different scope, different function or class. Yeah, it should probably have its own cursor. A cursor is sort of like a session into the database. But the big message here is if you're changing, if you're mutating data, which by the way, that's not going to be your normal task. Reading data, selecting data is far more normal. Changing things is dangerous. But if you're inserting or updating, by the way, we haven't introduced that yet. Maybe we'll play with it tomorrow. Update, or Thursday, because tomorrow's Mongo. Update is how you change an existing thing. So not insert, but edit, basically. There's also insert or replace. There's all sorts of things. You don't need to worry about all of them, but when you do them, you should always commit at the end. Just think of that. That's like hitting Control S for the database. And that's what we failed to do. So a few other things. We didn't get to this, but if you want to play with trying to write to a database, yes, we are hitting a lot of stuff. The sprint challenge will be focused on writing SQL queries that are based on select, and then conceptual questions for other topics. But select, join, or where, and possibly inner queries. Being able to select fancy things, or at least moderately fancy things, would be a good skill to work on. This other stuff, conceptual level, is okay for the sprint challenge. So I want to call it, but I want to very quickly show that link might be useful for the assignment for today. The assignment for the day, I bet you Austin is going to start a few minutes late anyway. The assignment for the day is, well, the Titanic strikes back. I checked in the Titanic data. It's a CSV of Titanic people. Make a table in the cloud in Postgres to represent Titanic data and insert that Titanic data. Get it out there, and then you could play with it with select if you really want, and do some practice that way. See the fanciest queries you can write to see averages and things like that. There's a link hint here. Enumerated types may be useful. Enumerated types in Postgres let you specify categorical things. Sad, okay, happy, right? There's categorical variables in Titanic, as you all know. But there's other variables too. So figure out your schema, figure out writing some code to insert it. I suggest not looping over every row individually. I suggest trying to stitch it together more creatively in one really long insert statement. If you just add the strings together, that should work, right? We inserted multiple rows in the very first example, and that's also in the training kit. So use PsychoPG. If you have problems with PsychoPG, ask for help or try PsychoPG binary. And if you want, it is encouraged. That link I dropped you could just try using it as a data frame and then having pandas do all the hard work for you. If you do this and you get this to work, that's very cool. Share it. I also encourage you to actually try to fight with the create table and insert statements yourself so you learn what they are a bit more. But this is how I would actually do it in production. I wouldn't hand roll all my SQL. SQL is a sort of language that when you're a full engineer, you usually write code that writes SQL for you. All right. On that note, thank you, everybody. I will let you go.